Good morning. My name is Daphne Weisham. I am the CEO of Methane Action. Welcome to the Methane Removal Imperative. We are joined by an array of impressive guests here this morning, whom I will introduce. But first, let me just say a little bit about Methane Action. We are a nonprofit organization with a unique mission to identify solutions that can rapidly reduce atmospheric methane concentrations to pre-industrial levels and ensure their implementation for the benefit of both present and future generations. Yesterday, we heard a lot about pledges to cut methane by 30% by 2030, with over 100 countries pledging to do so. However, the UN Environment Program tells us we need to cut methane emissions by at least 45% by 2030 to avoid exceeding a 1.5 degree Celsius rise in temperatures. Methane levels in the atmosphere are over 2.5 times higher than pre-industrial levels, higher than at any time in the past 800,000 years, and rising. Today, you'll be hearing from leading climate scientists and policy experts who will show us what must be done to begin to restore atmospheric methane to safe pre-industrial levels, allowing us to potentially keep temperature rises below 1.5 degrees Celsius by both maximally reducing methane and other greenhouse gas emissions while simultaneously scaling up technologies to remove methane from the atmosphere. In fact, methane removal technologies combined with other greenhouse gas emissions reductions have the potential to actually restore atmospheric methane to pre-industrial levels and roll back radiative forcing by 15 years or more. So to help us make sense of what is possible with methane removal today, we are joined by Dr. Lena Hoagland Isaacson, and I'm sure I've mispronounced your name, I apologize, Senior Research Scholar at the International Institute for Applied Systems Analysis in Austria, Dr. Martin von Herpen, who is a science advisor to Methane Action, Dr. Renaud de Richter, also a science advisor to Methane Action and a researcher at the National Engineering School of Chemistry of Montpellier University in France, John Fitzgerald, lead attorney for Methane Action, and Dr. Sean Fitzgerald, director of the Center for Climate Repair at Cambridge University. So starting with Lena, what is the global methane pledge and how far will it take us towards staying on a 1.5 degree trajectory as outlined for methane in the IPCC's latest assessment?
Thank you, Daphne. So I will share my screen. Can you see it?
Yes.
Yes, okay. So the Global Methane Pledge is an initiative from the European Union and the US, which has now gained support, sorry, I have to click here, that has now gained support from more than 100 countries and counting. And the target is to reduce methane emissions from human sources by 30% between 2020 and 2030. And as Daphne already mentioned, UNEP's global methane assessment report from this year says that 45% is needed by 2030 to stay at the 1.5 trajectory as outlined by the IPCC, whereof 30% will be easy at low costs to achieve and could limit the global warming impact by up to 0.3 degrees. But this would still leave about 300 megaton per year in 2030. So what to do after 2030? Well, in this graph from IPCC latest assessment report, we see that methane emissions must be cut to below 200 megaton per year by 2050 and coming close to 100 megaton per year by 2100 to stay at the 1.5 trajectory. Thank you.
So how realistic is it, Lena, that we stay on the 1.5 degrees Celsius trajectory?
Well, in 2050, the 1.5 trajectory means implementing and exhausting the entire technical potential that we know of today to roughly half anthropogenic methane emissions. So a large technical potential at very low cost exists for emissions from oil, gas, and coal extraction, as well as from waste and wastewater management. But the technical potential is much more limited for the agricultural sector. And for substantial reductions in that sector, it would require cuts in animal stocks that would have to be driven then by reduced demand for meat and dairy products. So to stay at the 1.5 trajectory in 2100, we would need additional technologies than we know of today.
So tell us a little bit about methane removal. This is obviously the topic of this conversation here. Can you describe for us what we mean by methane removal?
So methane removal means removing technologies that can remove methane directly from the atmosphere. So reducing the concentration of methane in the atmosphere.
And if you would like to, you can probably stop sharing your screen. I wanted to let our listeners know, if you have any questions, you can tweet at my Twitter account, which is Daphne Wysham, DaphneWysham, and we will try to get your questions in. How can methane removal technologies help in further limiting the warming potential from methane, Lena?
So methane action wants atmospheric methane to be halved from the 2020 levels by 2050, which is like mitigating and removing almost all anthropogenic emissions that are released today per year. So a joint effort to implement both abatement and removal technologies can remove the warming impact from anthropogenic methane emissions and restore the atmospheric methane concentration to the pre-industrial level.
Okay, so I'm going to turn over to Sean to ask you, Sean, if you can give an overview of one method of methane removal, namely photocatalytic oxidation.
So photocatalytic oxidation of methane involves getting the, well, when we're talking about atmospheric levels of methane concentration at the moment, getting that air in touch with a solid surface onto which is deposited a very thin layer of a photocatalyst. And the idea being that there are some very well-known photocatalysts, like some of the metal oxides, titanium dioxide, zinc oxide. And when methane is in contact with some of these photocatalysts, what happens is that in the presence of sunlight or ultraviolet light, they basically get over a little energy hump and then oxidize into carbon dioxide. So there's clearly a natural energy state from CH4 to CO2. We wouldn't be burning CH4 and making electricity if there wasn't a release of energy. But in terms of to make the oxidation happen at very dilute concentrations, you've got to get it over a little energy hump. And that's what these photocatalysts do, Daphne. So the idea of being able to use this approach to see whether we can remove methane, but we're removing it by converting it from CH4 to CO2. So although that might sound a bit odd, that we're not really doing methane removal and taking it away and burying it somewhere. We're actually converting it to something else perhaps we don't like. CO2 is rather less potent than CH4 as a warming gas.
And Renaud, can you elaborate a little bit on that? How does, tell us more about the status of research and technology with regard to photocatalytic oxidation of methane?
Yeah. In fact, photocatalysis activates the catalyst by sunlight and at ambient temperature, which is really a great advantage. So we can try to do the reactions outdoors. And as Sean has just said, we need to put in contact the photocatalytic surface with a huge amount of air because the methane is at very low concentrations in the atmosphere. It's about 1.9 ppm. And we have to put in contact the methane with the photocatalyst and also the oxygen from the atmosphere. And at the laboratory scale, this works pretty well in closed hermetic reactors that we call batch reactors. But if you want to work using a continuous process, things are slightly more complicated. If you use an airflow of some liters per minute in the laboratory at a laboratory scale, the reaction speeds and conversion yields are very correct, especially if the concentration of methane is relatively high, in the order of 1000 ppm or more. But when you choose to scale up a continuous flow reactor to deal with these lower concentrations in the atmosphere, things are more complicated. A careful design of the continuous flow photocatalytic reactor has to be made in order to increase the contact between the reactants, which are already said, which are methane, oxygen, and catalysts. So the lightning and the airflow speeds are very important parameters to take into consideration. And there is a fire alarm outside. So you have to take into consideration the cost of the energetic cost of this airspeed and lightning. And some teams, in particular one in Edinburgh, are working to use natural airflow and sunlight. And our team has proposed to use giant solar chimneys, which can be built for another purpose, which is generation of carbon-free renewable electricity. So for the moment, these things are at the research step, and it looks like the best possible applications for methane removal with photocatalysts are at point sources, such as the ventilation systems of abandoned coal mines or animal boundaries, or for instance, above landfills. I hope this answers your questions.
Thank you, Renaud. What are the positive attributes of photocatalytic oxidation as opposed to other approaches to remove methane from the atmosphere?
Yeah, in fact, that is the low cost if you are using natural air draft, and also that it happens at atmospheric temperature, and you don't need, and you can use sunlight. So these are the very positive attributes, but the problem is that the atmosphere of the Earth is really huge, and so if you want to have a significant effect, you have to move huge quantities of air. That's why I say that the advantages, the best applications are for the moment at point sources.
Are there any downsides to photocatalytic conversion of methane?
No, in fact, the very first step of oxidation of methane, which is a very stable molecule, is the most difficult. But once it has been oxidized, you have an intermediate product, which lifetime is really very short compared to other products. So it goes readily to carbon dioxide. It passes, of course, through several intermediates, and there is no risk. And also, it is the natural way it occurs in the atmosphere. So anyway, we are just accelerating the speed rate of the reaction, and it's all the way it occurs naturally.
Thank you. Next, I'm going to ask Martin. Now, you're involved in another experiment. Tell us a little bit about the iron salt aerosol method of removing methane from the atmosphere.
Thank you. Yes, my name is Maarten van Herpen, and I'm a senior scientist with Methane Action. And the idea behind iron salt aerosol is to enhance the way how nature is removing methane from the atmosphere. And we rely for this on iron salt aerosols, which is based on, if you first look at what is the main remover for methane in the atmosphere, it's actually two molecules. One of them is called hydroxyl, OH, and the other one is chlorine. And the chlorine actually comes from sea salt. It's responsible for about 2% of the methane removal of the atmosphere. And what happens above the seas is that the waves are crashing and they are creating these salt aerosols above the sea. And that's where the chlorine comes from, and the sun shines on it. And the idea behind iron salt aerosol is to augment that. And what we found in the lab is that when you add a little bit of iron with those salt particles, that then they gain a superpower. They can then generate up 10 to 100 times more of that chlorine. And that's important because it means that it's also removing 10 to 100 times more methane. So that's the effect we try to use and to see if we can solve the problem that Renaud was sketching of the need to move a lot of air, because this happens in the atmosphere.
So what's the status of the research right now on iron salt aerosols?
Well, we found that ships are one of the main sources of iron above the oceans. And you can imagine that when you have these sea salt particles interacting with the plume of a ship that includes iron, that this can form these iron salt aerosols. So what our research is now focusing on is actually three things. So one of them is in the lab, investigating the properties of these particles, but especially we want to measure in a shipping plume whether we can see these iron salt aerosols and whether they are indeed also removing extra methane. And when we've shown that, then we basically have a proof of concept of this approach. And then you can start thinking about, can we emit specific these type of particles for methane removal?
So do you think that it's possible that iron salt aerosols could help us achieve the goal of restoring methane to pre-industrial levels in the atmosphere?
Well, in principle, yes. Of course, we have to show this thing still in the field. But for example, a thinking experiment is what if all of the existing sea salt aerosols, if they were iron salt aerosols? And then the 2% of removal that they are causing becomes 50 times as much. And that basically means that the methane removal from the atmosphere doubles. And that then results in halving of methane levels. And it brings us close to the pre-industrial level. And the good news is that you don't actually need to change all of the existing salt aerosols. What we can do is emit specific iron salt aerosols that are smaller, and that have and therefore they have a bigger surface area and they stay in the air a bit longer. And when you optimize them, you can gain a factor of at least 100 to 1,000 in the amount of iron that it would need.
So I'm going to turn to you now, John. You've been busy here at COP26 trying to get the message out about how we govern methane removal technologies. Can you speak a little bit about that?
Thank you, Daphne. I'm glad to. Yes, we've had a beginning of a good conversation with some of the delegates, the US delegation in particular, because that's where we're from, but also the envoy from the Netherlands. And so what we have done is suggest a draft declaration, which is an international legal term for something that can speak for itself. It does not need ratification by others, but it can be joined, rather like a pledge, but with actual teeth and timetables. We have developed a Methane Declaration, which has now been actually supported by a lot of different policy experts and scientists, in a letter that you can find on the methaneaction.org website. But we've also crafted a draft decision for the Conference of the Parties in the form that the conference would normally take. In this particular one, draws upon this 25th Conference of the Parties, reference to the Green Climate Fund, which was to encourage the Green Climate Fund to continue to collaborate with the Technology Center with a view to both strengthening cooperative action on technology development and transfer at different stages of the technology cycle. And this is exactly where we are. And they've urged the Green Climate Fund to make more resources available for just this kind of technology development and transfer. And within the streams of work at the COP, there are several avenues where this could be taken up. Article 6 in discussing how developed nations deal with developing nations and working together to mitigate climate change and greenhouse gases, and also the financing and the work stream on implementation. But moving on, we also cite in this decision the October 21 resolution of the UN Human Rights Council, which declares that a clean, healthy, and sustainable environment is a human right, and establishes a special rapporteur on climate change with whom we would direct the parties of the Conference of the Party to cooperate in developing the following. We would develop and have the parties to the declaration ensure that all jurisdictions are aggressively reducing emissions first, and also while restoring ecological functions so as not to artificially constrain the functions of wetlands and forests, which sometimes give and take methane. 2, fund and initiate programs to monitor atmospheric methane. 3, initiate programs to develop technologies that reduce atmospheric concentrations of methane safely and effectively. We've named in that paragraph the several different methods by which we would do this, as we discussed earlier today. 4, to frame and implement global governance on the use of such methods, to return atmospheric methane to pre-industrial levels. We say governance because we do not want this kind of technology to be underdeployed, overdeployed, or improperly deployed. And together we can make sure that that does not happen. Then we would ask that the nations themselves develop regulations for both emission reduction and removal of methane by August 31, 2022. It's a short timetable, but frankly, the US is in position to do just that with its methane rules that the EPA is now proposing and seeking comment on. We will comment on those. And other nations can do likewise. The EU is in the process of dealing with methane regulations itself as well. And then we say to turn to international rules and programs by November 30th, 2022. That date is chosen to allow Conference of Parties 27 to consider integrated governance of these methods. And those in turn would require the development of the technologies to assess and deploy them after proper consultation with all affected peoples, and to then plan and prepare to implement these at scale, depending on which technologies are available, by the spring of 2023. This seems rather ambitious, but the challenge is ambitious, and that is why we've done this. And indeed, as I say, we have some extremely experienced policy experts who say this can be done. People who used to work in the White House Office of Council on Environmental Quality, coordinated all environmental policies for the US. One of the initial directors, the long-term chief counsel, who worked for both parties, a variety of true experts, both in the sciences and in law, have said, let's do this. Thank you, Daphne.
Yeah, among our signatories, which you can find on our website, methaneaction.org, is Dr. Lena Baer. Is that her name? Do I have her name correct from the White House CEQ?
Dinah Baer.
Dinah Baer.
She was there 25 years.
Dinah Baer, Michael Mann, Gus Speth. It's quite an extraordinary list of signatories. I encourage people to check it out on our website. I'm going to turn back to you, Martin. In terms of the iron salt aerosols, what is the process for review of this to make sure that it's safe, and also the citizen engagement?
Yeah, thank you. Yeah, what we will be doing, of course, next to the field test, that we will be measuring with optics in a shape of a plume. We also want to know what is the environmental impact of this if you do this at a large scale. Because initially this will be small tests, but what if you do this as big as we just discussed in getting it back to pre-industrial levels, the methane? And for that, we're doing global modeling in order to really understand where in the world we should apply this. And we also, we do already a full-scale environmental impact assessment. And that's even though we think that there are reasons to believe that a large-scale deployment of ISA is going to be positive. Of course, it restores methane to a pre-industrial level, and that's a good goal by itself. And then also things like iron-rich dust is common above the oceans. It drifts over from the Sahara Desert. And of course, sea spray aerosol is already there from the sea. And that chlorine, high levels of chlorine are also present in some places in the world. And with regard to ozone, there are some advantages as well, because it will help protect the ozone layer in the stratosphere, because methane at the high levels near the ozone layer is bad for the ozone layer. And we reduce the methane, that's good. And we can also remove ozone pollution more near the surface where humans live. But all of this needs to be checked. And that's why we do that at large scale global modeling to really understand the positives and the negatives and how to use this.
So in terms of what could go wrong and what could go right with the iron salt aerosol work, Martin, can you elaborate a little bit on that?
Yeah. So one of the things that go wrong also has to do with policy on this, because I think Lina already mentioned this. There's only one opportunity to get methane back to the pre-industrial level. That will save a lot of future warming, not if it's used as an excuse to keep emitting CO2 and methane in the meantime. And that's why there's really a need for a policy context, a policy that makes sure that the methane removal that happens at the same time as emission reductions, because only then it would really help to put the climate back on track for the Paris targets. Now, and on the side of more the environmental effects, some of the things we're looking at is, for example, the effect on ozone. Ozone is a pollution near the surface of the planet where humans live, and ozone is bad for human health and it's bad for crops. And when chlorine is enhanced, this gets rid of that pollution, and that will be a good effect. But in some cases, it can also increase the ozone pollution, and that's something we need to understand with the global modeling, because it will tell us where in the world is a good place to use it and where you should not use this. Another thing that we look at is the effect of the iron, because there is iron emissions that we're using. They are small. I didn't mention this yet, but the amount of iron is very low. Calculations that we did, it would be a very cost-effective solution if it really works what we're doing. And that iron will deposit in the oceans. And we also want to do the environmental impact assessment if this has any effect on the ecosystem over there. We think it's going to be very small because it's much less iron than is naturally occurring, but we are also investigating all of these questions.
And in terms of funding, what sort of funding do you have for this work, or do other folks on this panel, is that a handicap right now?
For us, funding is the main barrier. This field of methane removal in general is a niche. It's an area where nobody else has been looking at, and there's very little funding for research in this field. And I think that will be, for me, the biggest call to action from governments also, is to fund the development of methane removal technologies. All the ones we hear about today are in desperate need of funding. And it's urgent to get this funding, because Lina sketched this, very soon we're going to need these type of technologies to stay on track for the climate targets.
So Sean Fitzgerald, one of the arguments that I've heard whenever I talk about methane removal with colleagues in the environmental movement is, well, first we need to focus on anthropogenic methane emissions and get them down. And otherwise we are potentially playing with fire. There's the moral hazard argument that comes up where people say, will this allow business as usual to continue? Can you explain for us how you handle questions like that around moral hazard?
So the moral hazard is a real issue, because I think it's a very important question to be posing about, and we should all be worried, I think, about the risk that if we come up with a solution to go and take greenhouse gases out of the atmosphere, whether that will lead to behaviors which are not basically aggressively reducing emissions. So I think it's a very valid question. However, we are now in a very different situation from where we were 10, 20 years ago. And the IPCC AR6 report, Working Group 1, released just a couple of months ago, made it extremely clear that even their most ambitious, you might say aggressive, emissions reduction scenario sees temperatures going through the 1.5 degrees sea level. Now, admittedly, the most ambitious scenario then dipped back down below 1.5 by the end of the century. But nevertheless, it was above 1.5. And we are now in a situation where it's not one or the other. We can't just get away with sorting out our climate just with emissions reductions. And we've got to therefore develop approaches which allow us to not only turn off the taps of water going into the bathtub, we've got to drain that bathtub. Greenhouse gases right now are too high. And the way that I think we should be framing this issue about the moral hazard is certainly not to be listening to people of our age and generation, but to be listening to the younger generation. And what do they think we should be doing? These voices are really, really important. Actually, I think we do not have an issue of a moral hazard. I think we have a moral duty to be actually doing a lot more. In other words, developing approaches to then go and repair the climate, to go and actually reduce greenhouse gas levels that we currently have to more sustainable levels. And frankly, if we don't do this, then we have a dereliction of duty issue. So I think we just need to broaden the conversation. And it's not just about a moral hazard. I think we've got some very deep philosophical issues at stake. And the voices that we need to be listening to are those that perhaps we haven't given the microphone to as yet, Daphne. It really is about sort of making sure that we can't just rely on emissions reduction. We need that, and there's no point in turning off there's no point in draining the bathtub if the taps are still on, and that's the whole point. You need to do both.
Lena or Sean, can one of you speak to the natural oxidative capacity of the atmosphere and why it is that apparently we cannot keep up with the quantity, the atmosphere cannot keep up with breaking down the quantity of methane that is flowing into the atmosphere? I don't know if either one of you want to take that question. Lena, do you want to take that?
Maybe I can start and maybe
Okay.
Sean can continue. So we have to understand that currently about 2/3 of the methane that is up there in the atmosphere now comes from human activities, and only 1/3 is from natural sources. So what we're talking about here is removing 2/3 of the concentration of methane that is in the atmosphere. So humans are definitely by far the biggest contributor to the methane that is up there now.
But in terms of the natural oxidative capacity, is it true, Sean, that we have somehow sort of broken that mathematical formula where there's enough oxidative capacity with the chlorine radical and the hydroxyl radical and the methanotropes and others to break down the methane that is ending up in the atmosphere? Is there? Can you explain a little bit why it is that the natural oxidative capacity of the atmosphere is not keeping up with the pace of methane that's being released?
So, I mean, the way that I think about this question and how to answer it, Daphne, is going back in time to pre-industrial levels. So we have a previous state whereby, why was there methane in the atmosphere anyway? And that was because we had a natural system where there were releases and they were being matched at a certain level by, for a given concentration, therefore the oxidation. And that's a natural system. And as Lena has said, what we've done in large part is now increase the flux of being generated at source. So fundamentally, you've still got the same natural processes going on, but we are now approaching a different, if you wanted to say, for a given state, a given emissions rate, we're going to arrive at a very different steady state because, and it's going to be very, very unpleasant. And we're certainly not in that steady state at the moment. So the emissions, the levels of greenhouse gas are continuing to rise, Daphne. And it's therefore we've got to, on the methane issue, we've got to certainly turn the taps off. What gives me a cause for concern is that over and above the sorting out anthropogenic emissions of things that we can get to grips with. So, for example, the oil and gas, and therefore leaking pipelines. We've already heard that we might be able to do things to some level by changing diet and reducing our reliance on dairy. But we've still got agricultural challenges, just with releases of methane from from normal agriculture and with an increasing population. And then what really scares me is, as a result of temperatures rising, and then what was previously permafrost, and it no longer being as perma, and therefore the releases of methane from the likes of the Arctic. Gosh, this really does get me very exercised, and why we need to therefore incorporate methane oxidation, methane removal from atmospheric levels, Daphne, as part of our portfolio of tackling climate change.
Yeah. So what I hear you both saying is agricultural emissions are the most difficult to mitigate. And in addition to that, there might be some surprises awaiting us with regard to methane releases, either from the Arctic or from other natural sources. Martin, can you add a little bit to this imbalance between the methane that's being released into the atmosphere versus the capacity of the atmosphere to oxidize it?
Yeah. So because it links back to the way how nature is removing methane. So methane has a limited lifetime of about a decade, and so that means that when it's in the air, it stays there for about 10 years or so. And so you could compare then methane with a bucket with a hole in it. And when you put water in the bucket, and it will flow out on the bottom, and then if you do that, there's a little bit of water that stays in the bucket itself. And with methane, that's the methane level. And there's a balance between what goes in, which is the emissions, and what goes out, which is the hole that you have in the bucket. And what's been going on is that more and more emissions. So we've been putting more and more water in the bucket. And what we want to do with methane removal is make that hole bigger, so that more can also flow out. And in that way, get the level down. So hopefully that illustrates a bit what's going on in the atmosphere.
Renaud, did you want to add to that explanation?
Yeah, because in fact, it's counterintuitive, but all the pollution we are emitting in the atmosphere has slightly increased the oxidative capacity of the atmosphere, and in particular, the hydroxyl radicals. So if we succeed, and we will succeed, to stop fossil fuel burning, then we will reduce the pollution, and that will automatically also reduce slightly the oxidative capacity of the atmosphere, in particular due to less emissions of NOx, of nitrogen oxides. But on the same time, global temperatures will keep going up till stabilization. And there, the permafrost melting will continue. Also, the warming will produce on wetlands more methane. So the quantities of natural emissions of methane will go up, and the oxidative capacity of the atmosphere will go down. That's one of the reasons why we need to increase the oxidative capacity of the atmosphere, or at least to keep it like it is now, and aerosols are able to do that.
And say a little bit about NOx and why that is important to oxidation of methane.
Yeah, it's rather complex chemistry, but yeah, in fact, the atmospheric chemistry of nitrogen oxides increases the amount of hydroxyl radicals, and the hydroxyl radicals are the main detergent of the atmosphere, and they destroy 99.5% of the volatile organic compounds and up to 90% of the methane. But it will decrease if we decrease this pollution, which is rather counterintuitive. That's it.
So, John, I'm going to turn to you now. We had a little bit of a back and forth on moral hazard. Now, this is something that's front and center in our thinking on the methane governance, methane removal governance process. Can you speak a little bit to that?
Yes, I'd just like to build on what Sean Fitzgerald has already said by saying that we have many tools in the law for dealing with this moral hazard possibility. For instance, if we just left it at offsets, there would indeed be a moral hazard to trade one for the other. But the governments have now understood, the US government, the European Union, and others have understood you can't do that. And they are going to require, I do believe, and I see in EPA's work, the best possible reduction from sources that technology can provide. And there'll be a number of folks helping them to do that. And there are others petitioning EPA in the near future to use other authorities, and they've even thought of using, that they do have, that former councils agree that they have. And so we can require the retrieval of methane by those that put it out, if you use those authorities. And furthermore, as Sean has said about restoration, the world has in principle adopted the duty to restore degraded ecosystems and not harm the environment of others in the conventional biological diversity. No nation has really yet triggered the dispute resolution process, but there are many nations whose ecosystems have been degraded by excess methane, and they can begin that process. And now the courts in Europe are beginning to say the human rights law has teeth, and they've directed governments to come up with better plans than they already have. And so we have a different set of powers in the law, driven by citizens, driven by those that are harmed, driving us past the moral hazard argument and get this done. So that's what we'll continue to do.
I'd like to spend the next few minutes talking about the positive vision that you all have and why you do this work. I know for me, after 30 years of doing work in the environmental arena and trying to take on some of the biggest banks in the world on their fossil fuel investments, we made some progress, and it was gratifying to see some of that progress. But of course, as Sean pointed out, and apparently the IPCC agrees, we are not going to achieve limiting global temperature rise to 1.5 degrees Celsius without removing carbon from the atmosphere. So 1.5 is one destination, and that's certainly captivated most of the world. We have this slogan, 1.5 to survive. What's your slogan, Sean? How do you look in the crystal ball and look forward and see something a little more optimistic than 1.5? Because at 1 degree Celsius, we already are seeing just devastating climate impacts all over the world.
So there are two things, Daphne. The first thing that excites me is latching on to everybody. The dialogue right now, we had it only yesterday, in terms of India's commitment to this thing by 2017. It's called net zero. And I like the double entendre of net zero because it's an issue that's often skirted over. What do we mean by net zero? Well, the double entendre is negative emissions technologies, right, of the net bit. So it's the balancing of greenhouse gas emissions with actually things that we can then do to take stuff out of the atmosphere and sequester those. And I get excited about if we can really get to grips with negative emissions technologies in order to at least get people comfortable, they already are, but reaching targets on net zero. We then need to work harder at those technologies, scaling them up so that we can then start to see a reparation of our climate and therefore bringing greenhouse gas levels down. So, I mean, I see opportunities in the negative emissions technologies. We are literally, at the very starting point for many of these. Some of these, we're working on a project on, actually not to do with methane, it's a carbon dioxide project, but it's using current industrial processes that have been cobbled together. So to go and start making stuff happen, and we're doing some development on that. Even the most advanced companies right now, Daphne, are at the nascent stages of what we really need at the scale for the climate to go and get us to anywhere close to net zero. But I get excited because on the subject of methane removal, for example, where we've heard about iron salt aerosols, we've heard about photocatalytic oxidation. There are further processes too, which is, for example, dealing with higher concentrations coming out of coal mines and things like this. If you have higher concentrations, if they're really high, you can burn it and make electricity. We've got some companies that we've been liaising with that do that. Slightly lower concentrations or lower flow rates where it doesn't actually make sense to burn it. and make electricity, you can use thermal catalytic oxidation. And it's these lower ones that we're worried about, which is in the atmosphere or from just from leaking from open cast mines, where we need to look at photocatalytic oxidation. I'm excited because some of these approaches and the ones that Renaud was describing could potentially be applied at really large scale. If we can get coatings onto the built environment, coatings onto buildings, coatings even onto vehicles, if it's coatings within ventilation ducts, I see so many wonderfully positive things. One on the photocatalytic oxidation of methane that excites me. With one of my other hats, Daphne, is looking at our concerns regarding COVID in the built environment. And one of those techniques has been suggested using UV within ventilation ducts. Well, Renaud, if we have UV within ventilation ducts and then coat the ventilation duct with some photocatalysts, maybe we're killing more than one bird with one stone. And I think some really creative thinking about what we can do, and we can maybe get the license to go and do this, the money to go and do this as a result of COVID at the same time as then getting real on the climate. So I see some wonderful opportunities in the area of greenhouse gas removal, Daphne. And I'm going to let others speak, but I'm also very excited about some of the solar radiation management ideas that we need to progress as well. But that's for another day. We're here talking about methane.
Yes. So net zero. Lena, how do you feel about that?
Net zero, you mean?
Well, I guess my question for you is what is your positive vision, and how do you see us getting anywhere close to climate restoration?
I think it will have to be a combination of emission reductions and removal technologies, depending on a bit on the costs of both. And when it comes to the emission reductions, I think there is a very positive development right now in the monitoring technologies that are now developing, because until now we have not really been able to monitor and verify methane emissions directly. Now this is becoming possible from satellites, and also in the future from nanosatellites, if we can build networks of that, to really focus on the monitoring, because that's a game changer from a policy point of view, to be able to actually verify emissions. So I think that's a very positive development. And I think in general, I think it's a very positive development that methane is now climbing high on the political agenda, because I've been working 20 years with methane emissions. And until now, it's been a lot of focus on CO2 emissions, and methane has kind of always taken the back seat. And now methane is climbing, and that's very positive, because it's really something that we need to focus more on.
John, do you have a positive vision you want to share?
I certainly do. And I'll start with the environmental impact statement process. Done right, that involves comments at the very beginning and comments on the draft by all affected communities. And this can pertain to local effects, such as those in the northern latitudes in the Arctic, who are being affected rather directly by climate change more quickly than anyone else. We've talked to some of our friends in the native communities up there who are eager to be involved in identifying where the leaks are and solving those leaks. And as Lena said, we have technologies to help them do that now. They can be sort of a ground truthing and also tell us what we need to do for the natural leaks that are beginning to open up there too. They can be partners. And in this, we can heal some of the wounds that may have been opened up in previous years when people simply said, this is what we're going to do to you. We can do things together and plan things together through the AIS process. And in that process, we can learn to be more cognizant of what we're doing to each other and for each other in all other areas too, because this is indeed a global venture with local activity that's necessary.
Renaud, one of the other pushbacks that I've gotten on methane removal as well, methane's half-life is so short. So, and it naturally breaks down readily. We need to keep our eyes focused on CO2 removal, not methane removal. What do you say to that, Renaud?
Yeah, in fact, we can deal with methane more easily than with carbon dioxide. And if we want to stay in the Paris goals, if possible, lower than 1.5 degrees Celsius, the only solution is to really reduce the current warming due to methane. And if we stop emissions of carbon dioxide and if we get net zero, that will not reduce the temperatures, that will stabilize the temperatures. But if we succeed to restore pre-industrial levels of methane, then we can reduce the temperatures by 0.3 degrees Celsius or 0.4 degrees Celsius. And that will help not to have an overshoot of temperatures above 1.5 degrees Celsius. And that will help stabilize the temperatures much easier than just working on carbon dioxide. So we have to do both. We have to reduce carbon dioxide emissions. We have to reduce methane emissions, but we have to do methane removal also to come back to pre-industrial levels.
The way I look at it, methane is a sprint and carbon dioxide is a marathon. And the sprint is both getting methane levels down as quickly as possible, dealing with anthropogenic methane emissions as quickly as possible, and at the same time, scaling up the methane removal technologies so that by the time we've squeezed as much out of the global system of anthropogenic methane emissions that we can turn to methane removal technologies, ideally sooner than that. But Martin, what do you think? What is your positive vision for this work?
I agree with you. If you could see that CO2 and methane are two different types of pollution or waste. CO2 is the type of pollution that ends up in a landfill. And when you stop creating that pollution, the landfill is still there. So stop emitting CO2, still the heating stays. Methane degrades by itself. That's the natural way how it's destroyed. So we just have to stop emitting methane for it to go away. And that's why it has such a short-term impact. And that's what I'm also excited about. It's a third of global warming. And if we stop emitting it, it will disappear, that amount of warming.
But there is still natural biogenic sources of methane.
Yeah. And that's why we need to have a combination of stopping the emissions and removing some of the other emissions. And in combination, very quickly, we would be able to deal with that big amount of heating.
And your calculations suggest we can potentially roll back climate forcing by how many years?
Yeah, because it's a third of global warming. So you could calculate how many years it has taken to do a third of global warming in that time. But we would estimate that if you just get methane back to pre-industrial level, that's like going back to the amount of heating that we had 15 years ago, or maybe even more. So that's a very big step, and that's why you gain so much time also for handling the CO2. Because that's a more difficult job. That's the landfill that still needs to be cleaned.
Well, thank you all. I'm going to leave it on that positive note. And thank you all for joining us. Again, this is Daphne Weisham with Methane Action. To learn more about our work, visit our website, which is methaneaction.org. And we will be having another event on November 8th at 4 p.m. Glasgow time with a different set of speakers. So join us then. And thanks so much for joining us.